Hello, everyone. My name is Thomas Fitzgerald, and this is DSIM Class 420 with Professor Argawal. This is the final assignment. The purpose of this assignment was to choose a data set and then analyze that data set and create visualizations using Tableau as well as RStudio. I went ahead and chose the retail case study data set off of Kaggle because it met a few different qualifications that I really liked, one of which had a good fair share of both numerical data and character data types, which made it easy to draw meaningful conclusions from my data, from my visualizations in Tableau. So this data set actually has 3 different spreadsheets. I'm going to go ahead and skip off of Kaggle now, and I'm going to jump right into showing you guys the spreadsheets. So right here is the spreadsheet that shows all of the transaction data, such as transaction ID, customer ID, transaction date, product subcategory code, product category code, quantity rate, tax, total amount, and store type. It's important to know that there is 4 different store types. There's the eShop, the Teleshop, the MBR, and the flagship store. Moving forward in the visualizations, you're going to go see all 4 different stores and how data from them is utilized. Next is going to be the customer spreadsheet, which shows the customer ID, the date of birth, the gender, and the city code. Also important to note in this is that gender has both male, female, and non-binary. However, non-binary only appears very few times within the data set. And then we have product category code that goes to a specific product category, and then the product subcategory code that is also assigned to a specific product subcategory. So now I'm going to go ahead and jump right in Tableau and go ahead with talking about my graphs. So one thing that I had to do before moving forward was I did have to provision the data source. Right now I'm getting an error for read permissions, and I'm not sure why. But being that there was 3 different spreadsheets, I had first joined the spreadsheets so that I could get everything within this data column over here so that I could then create my visualizations. So the first one is going to go ahead and show what is the tax rate for each product category and what about for each store. Like I said, we have the eShop store, the flagship store, the MBR, and the Teleshop. I actually created a calculated field for this one as well. I just want to show it to you guys real quick. So in order to get this, and this was one of my favorites, I had to do tax divided by total amount, and then I was able to get the average tax rate, as you see on the screen right here. So one thing that is kind of specific about this graph and what we can kind of draw a conclusion from is that the flagship store and the MBR are pretty similar in tax rates, while the eShop store and Teleshop store are also a little similar in tax rates, not so similar, but we can see here that some have similarities and some don't for each store shop. The most important thing being is that they all have different tax rates across the board. So maybe, for instance, if you want to buy bags from the eShop, you may look to buy bags from the Teleshop instead because the tax rate is significantly lower. Okay, and then right here, we're going to move on to the next graph, and this is what year had the highest dollar amount of sales and quantity sold. This graph is important because we can see from 2011 to 2012, it increases slightly. 2012 to 2013, it stays pretty constant. And then something happens in 2014 and it just goes off the deep end and severely declines. Moving forward in data analysis, if we wanted to go ahead and target and pinpoint maybe what caused this sharp decline, we could go ahead and find that and then draw conclusions from that. So the next one was, do men and women buy significantly different products? Throughout these graphs that I'm going to show you, I do have a few gender graphs, which in my opinion actually show very important statistics and what we can do to improve sales and quantity within a specific city or within a specific product. So here we're going to go ahead and see that men and women have similar book sales, and then non-binary, like I said, it appears very rare. However, we have it right here with 12 and 5 and 3 and 1. Electronics, 6,476, women, 5,832. So we can go ahead and see that men have, they buy more electronics than women. Next, we have what is the count of customers per store type. This just shows essentially the count of customers per each store type, with the eShop store having the largest customer base. Then we have what cities have sold the highest quantity of each item. As we can see, this one was pretty interesting. Books are the highest items sold consistently, as well as bags are the lowest item sold relatively consistently as well. I could even go ahead and do this as well so you guys can get a strong understanding and look of it. Go ahead and go back now. And this one goes ahead and shows what gender was the main purchaser according to each city code. I think this graph is pretty cool because it depicts not only the gender of each city code, but what we can draw from it is that maybe within city code 3, for instance, we can see that males are the main purchaser within that city code. However, we want to increase sales among females. So what we're going to go ahead and do is we can more targetedly advertise females within city code 3. Right here, I used a set for this actually, and this is what is the quantity of electronic items purchased from the eShop store. As we can see that electronic items from the eShop store, as well as all the other items, remained pretty consistent. And then we're going to go ahead and also see what is the running sum of quantity according to each category. As you can see, the running sum consistently moves up, and it's also dynamic as we can go ahead and press on. Then we have what are the demographics of each customer ID. So this one is an extremely large graph, but it is important to know that we can go ahead and filter. So like, let's say we wanted to go ahead and see city code 2. So this is all of the customer IDs within city code 2. And then let's say that we wanted to go ahead and see is customer 266945 male or female. We can go ahead and see that 266945 is actually a male. We can also just go ahead and filter. For instance, if I want to see city code 2 and 5, I can go ahead and do that. Next, we have which main categories have the highest quantity sold by looking at subcategory and category quantity. This one I used a parameter, and it is also dynamic. We have clothing over here. As you can just see, it's literally just which subcategories and categories according to quantity have been sold further. So this one's a pretty cool graph. And next, we are going to move into the dashboard section. One thing I wanted to do when creating dashboards was just remain relatively constant throughout my color scheme. I know people don't like to look at different rainbow shades and stuff like that. So for instance, I decided to put all of the gender graphs that I put within one dashboard. As well as this is dynamic, so you can filter by city code over here again, and then we're going to see it move over here. As well, if you go ahead and hover over it, we can also see city code 2, male, count of customers 302, city code female, count of customers 261. So we can also even see the count of customers, which is extremely cool. And then we also have books, electronics, home and kitchen, footwear, clothing, bags, and then we can also see, do men and women buy significantly different products, essentially. Then I have the tax rates and quantity of each item. So this dashboard is also dynamic. If you hover over everything, you can see that the average tax rate, for instance, in the flagship store for bags is 7.79%. However, in the teleshop, it is 7.228%. So if I want to buy bags, I'm probably going to buy a bag from the teleshop as opposed to the flagship store. And then the tax rates and quantity dashboard. And this one is also dynamic with the parameter being over here. And we can filter by that. And then if you look down here, there we go. We'll go ahead and see it move. So like I said, this graph I liked particularly because I am very interested also in what happened from 2013 to 2014. And then lastly, we have the story point. I'm just going to go ahead and read out the conclusions that I was able to draw from each graph from these story points. So for this graph, it was the average tax rate per store type tends to remain relatively consistent across product categories. There was a sharp decline in quantity of products purchased from 2013 to 2014. From looking at the decline in the previous slide, it may be wise to observe the types of items the customer base purchases, as well as other customer demographics. On average, men tend to make up a higher majority of the customer base throughout the city's codes, as opposed to women or non-binary. This being said, we can now use marketing advertisements to target women to increase and non-binary to increase those numbers. Observing the gender per customer ID, in addition to city code, each customer ID is registered. So each customer ID is registered and we can see their specific gender. Then we have the eShop, which has the highest customer base, while the teleshop has the lowest. Which I wonder, that's not surprising because I believe that it was the teleshop that had the lowest, I believe, overall tax rates. And then the items most purchased throughout each city code is books. The lowest is bags. This one is also cool. Maybe you want to increase bag sales within city code 1. Let's go ahead and push bags then a lot more than we're pushing books, because books obviously tend to do pretty well for themselves. The quantity of electronic items purchased from the eShop store remain constant. The running sum of quantity according to each category shows the quantity number increasing throughout various items. This one just says filter in regard to the amount of quantity sold. You can just go ahead and look like that, and then we can filter over here. Customer gender demographics dashboard. I just included this in the story point. I did the same thing with the tax rate and quantity dashboard and the quantity demographics dashboard. So that you guys have gone ahead and seen a little bit of Tableau, I do want to go ahead and jump into RStudio and show you the 3 graphs that I did create within RStudio. So one thing that I am going to have to do, I have my environment over here, bar chart, my prod line, my prod category info. I'm going to go ahead and import these libraries real quick just to make sure that they're in there. What are you doing, Art? Okay. Okay. Error in ggplot, could not find function ggplot. Well, let's go ahead and load the ggplot function then if it wants to. Okay, ggplot is loaded. Let's go ahead and clear this now. Okay, so we're going to launch that, and then we're going to go ahead and launch that. So this is the first graph that I created, and essentially it just matches the category code to its specific category. I hadn't previously put this in any visualization, so I wanted to go ahead and do that so that if we were showing this to maybe a shareholder or somebody who was like, oh, what is the electronics category code? Then we can go ahead and see that electronics has a category code of 1. And then over here, I went ahead and did the exact same thing with subcategory code. If we go and look at the spreadsheet, you can go ahead and see that the subcategory codes do repeat more than once, as opposed to for a specific product subcategory. For instance, both women and men have a product subcategory code of 1. And we also go ahead and see that right in here, men, women. And then actually one thing that I did want to do is we see that it's in decimals right now. If you want to launch that and then create it. So now it's not in decimals 1 through 12. We can clearly get a good visualization for now. And then the last is just going to go ahead and show the bar chart. And what this bar chart essentially shows is the count of unique subcategory codes according to their each product category. So for instance, we have 6 here, and we have for clothing, we have 3 here. And what this graph shows, it may be a little bit difficult to understand, but if you go ahead and look in this spreadsheet again, it's because clothing, for instance, appears 1, 2, 3 times. And then it has product subcategory 1, 1, 1. And then we can see here that clothing now is 3. So that's exactly what this graph does overall. So guys, I hope you enjoyed this presentation. This concludes the final project for DSIM 420. I think that these visualizations are overall important because let's say that we wanted to push marketing within a specific city, or push sales for a specific product, or maybe even see that decline from 2013 to 2014, we can go ahead and do that. So thank you.